G'day science fans! Get ready for a wild ride as we explore the amazing thermite reaction. This chemical reaction is a true spectacle of science, generating intense heat and light. It's a favorite demonstration for chemistry enthusiasts around the globe. Imagine a reaction so powerful it can melt metal right before your eyes. The thermite reaction is not just a dazzling display, it's a fantastic example of an exothermic reaction. Exothermic reactions release energy into the surroundings, usually in the form of heat. In the case of the thermite reaction, this heat is powerful enough to melt iron. This reaction is a great way to learn about chemical reactions and the energy changes that come with them. It highlights the principles of oxidation and reduction, where one substance loses electrons while another gains them. So buckle up as we delve into the fascinating world of the thermite reaction. Now, to create this fiery spectacle we need two key ingredients: aluminium powder and iron 3 oxide, also known as rust. We use aluminium powder because it has a high affinity for oxygen. Basically, aluminium loves to combine with oxygen. Iron 3 oxide, on the other hand, is our oxygen supplier. It readily gives up its oxygen atoms, especially when heated. When we mix these two powders, they look quite unassuming, like a simple pile of reddish-brown dust. But don't let their appearance fool you. These two seemingly harmless powders hold the potential for an incredible reaction. When provided with enough energy to kickstart the process, they'll unleash a dramatic release of heat and light. Stay tuned to see how these ingredients come together in a fiery display of chemistry. Now let's dive into the heart of the thermite reaction and understand the chemical tango happening at the atomic level. The key players in this fiery dance are oxidation and reduction, often called redox reactions. In simple terms, oxidation is like giving away electrons, while reduction is like gaining electrons. In our thermite duo, aluminium is the eager beaver, ready to donate its electrons. This makes aluminium the reducing agent. Iron 3 oxide, on the other hand, is happy to accept those electrons, acting as the oxidizing agent. When the reaction kicks off, aluminium readily gives up its electrons to the iron in iron 3 oxide. This electron exchange is what fuels the fire. As electrons move from aluminium to iron, a tremendous amount of energy is released as heat, sending temperatures skyrocketing. This heat is what makes the thermite reaction so spectacular and useful for various applications. Section 4. Setting up the reaction safety first. Before we unleash the fiery fury of the thermite reaction, let's talk safety, because with great power comes great responsibility. Remember, we're dealing with extremely high temperatures, so protecting ourselves is crucial. First and foremost, always wear appropriate safety gear, including heat-resistant gloves, a lab coat, and eye protection. A face shield is also a good idea to prevent any hot sparks from reaching your face. Next, choose a suitable location for the reaction. It's best to perform this experiment outdoors on a heat-resistant surface like a brick or concrete block. Never conduct this experiment near flammable materials. Remember, safety is paramount. Once you've taken all the necessary precautions, you can proceed with mixing your aluminium powder and iron 3 oxide in the correct proportions. And remember, never leave the mixture unattended once it's prepared. Section 5. Igniting the spectacle. Let the show begin. With our thermite mixture ready and safety measures in place, it's time for the grand finale, igniting the reaction and witnessing the fiery spectacle. Now, starting the thermite reaction isn't as simple as striking a match. It requires a source of high heat to overcome the activation energy barrier. In other words, we need a powerful ignition source. One common method is using a magnesium strip. Magnesium ignites easily, producing an intense white light and very high temperatures, perfect for kickstarting our thermite reaction. Another way is to use a high-temperature flame, like the one from a propane torch. Once you've ignited your magnesium strip or torch, carefully bring it close to the thermite mixture. And then, boom! The reaction takes off in a shower of sparks and blinding light, generating intense heat that can reach over 2,500 degrees Celsius. That's hot enough to melt iron and even steel.